Welcome, Randy. Okay, like I said last class period, this class period, each one of you is going to choose to solve one of these 5 derivatives for everyone else, and then one of these 5 integrals. So let's choose up now, and I'll start at the bottom and work my way up. Does anybody wish to solve integral E?
No, that's the one. No.
Anyone wish to solve, or integral, I meant derivative. Derivative E.
Oh, the derivative is fine. Yeah.
So you want to do that one?
Let's do it. Because wasn't that the one with the...
Okay. What about derivative D?
I'll try to solve the integral for that one.
The integral for it?
I'll try.
Okay, we'll when we get to the integrals, we'll sign you up.
Wait, I want to do A if we're choosing.
Well, we're choosing. Okay, so what about C?
I can take C.
Okay, C will be David. And then Randy, A or B?
B.
B is in bad boy? Okay, so that means I start. So I'm actually going to work out the 2 that you guys don't do. That way we've got them all covered in class to make sure that you can get them done, right? Because the goal here is to review and refresh, not to,
I'd rather do A.
Okay, Randy, question. So come on up, Oksana.
This is kind of like homework.
This is the homework, yes.
We just have to present, basically, not show you our work.
You're going to work it out and explain it.
I see.
So just go over to the right here, Oksana, and you've got your color pins up here.
Yeah.
You erase using this side, you write using this side.
Cool. Everybody see it.
Yeah. And so there's the problem. You scroll with your finger. I'm going to go sit down and watch.
So 5t squared minus 20t plus...
Well,
Yeah.
use the Surface Pro, right?
That's what that is.
You said you're having problems with your pen or your computer itself.
Well, it doesn't reject my hand like it's
So you think it's a tablet, not the pen or anything like that? Because the thing is, I have one too. I try to write with it. I get some scrabble every now and then. I've never had your issue.
It's
I
like-
want to like switch
Well,
pens or
that-
something. Try that.
That
Wow, that's bigger than life, isn't it?
yes, that's actually the newest greatest pen. But it's the hand rejection. So it's
I don't know if you wanted to explore because I had mine.
it's different with different apps.
Oh.
Which is probably why you haven't had problems like I have. Because using different
I use one all the time.
Where's the explanation?
That's
Yeah, we need the explanation. Remember,
So-
you could look all these up on, Wolfram Alpha. Just getting the answer is not the goal.
So what you do, can you see my cursor? Okay, so you take 2 times 5, as you guys know, and then you...
Okay, so write it down. Like you did.
So should I just start over?
Well, no, just erase that.
Just erase it? What was the initial color you had? Oh.
And remember, you can just use the backside of the pencil to erase.
Oh, really? Wow. All right, so we're going to take the derivative. I sound like a YouTube video.
It will be a YouTube video.
Yeah. Thank you for joining me. Make sure you subscribe, like, comment. So we're taking the derivative of 5t squared minus 20t plus 17. And so when you take the derivative, we're going to use the power rule. And so 5 times 2 equals... Huh?
Brought down the power.
Right.
Not equals. Well, no, it was all good except for...
So we take 2 times 5, which is 10. And then we just keep that t, just tag it on there. But then you see what's 2 minus 1? It's 1. So you just have it like that. And then you subtract, bring that subtraction sign. And 20t, the derivative of that, you just take off the variable, and it's 20. And then taking the derivative of an integer is just 0. So this is the answer.
There we have the explanation. Now, in your homework, I actually expect you to write 5 parentheses 2 t raised to the 2 minus 1.
Wait, no way.
Right, because I want it to be very clear what you did.
Okay.
Okay, who was next? I think it was Randy. Oh, that's where you put the equal sign. I was wondering why you put the equal sign.
Yeah, I know, right?
Right, like, here, come here, I'll show you later.
Do you want me to just erase her part?
No, just do it underneath.
Okay.
What was that number?
6 divided by T2.
Huh? Oh, 17. It was like plus 20. I think I'm really good. Yeah, you're right.
Do you want the answers in the original form they were in?
I'm not sure what that means.
Here, well,
For like integrating back to.
well, no, I was going to ask because I'm talking specifically this problem.
Oh, I understand what you mean. I don't care.
Okay.
Okay, so 6 divided by T2. How I started this is I saw there's a T2 or a T to the power of 2, excuse me, not T2, at the bottom. And whenever you have a power at the bottom, you can do this. So I just like to spread it out like T divided by 2, or T to the power of 2. That's just 6 times 1. But then this part is equivalent to T to the power of negative 2.
And that's the aspect you're talking about.
Yeah.
And then so since you have that there, you can combine the 6, which is 6 over 1, just equals 6. And then so from there, I like to use arrows a lot. But from there, you can go 6t to the power of negative 2 and do derivatives just as usual. So that would be 6 multiplied by negative 2, which is the power of our derivative of this right here. And that's t. And then so it's negative 2 minus 1. Because always when you do the derivative, you minus 1, whatever in the exponent. And so just doing the math, 6 times negative 2, that's negative 12. And then don't forget the t. And then negative 2 minus 1, that's just negative 3. And this should be your answer.
Now, one thing in the way you wrote it, for the last 2 lines, you should have something that says it's the derivative.
Right. Okay.
So just like she did, the f prime or something like that.
I see.
Yeah.
Beautiful.
All right, Chapman, your turn. I think he stuck to the right
Yeah,
side.
so to the.
It has magnets to hold it there, but of course, as soon as I start walking, it falls off. So
Right.
I use it.
Okay, so for this we've got, I think it was f of t equals 24e to the 3t. So what we have here is an e raised to an exponent of 3t and a constant 24 out in front. So this one's actually really simple. I don't remember what the rule is called, but what happens...
I just call it.
Yeah, that's what I was thinking. So what happens is you have 2 parts. You have your 24 and you have your e to the 3t. You can separate those out. The derivative of e to the 3t is e to the 3t times the derivative of the exponent. And the derivative of the exponent is 3 because it's just a constant times an unknown variable. So what you do is you take 24 times 3 e to the 3t, and then 24 times 3 to make it all balance out. Let's see, that's 72. 72 e to the 3t, and I believe that is the correct answer.
All right. That was easy, huh?
I did like that one. The next one I probably could do, but it's a bit more complicated.
Yeah, the next one's fundamentally the same thing.
Could you also use the product rule for this? That's what I did, but I got to 24 times 3. Just
Um,
like you did, but I just didn't do that.
You're talking about for D?
Yes.
or-
Or no, for C.
For C, no, you wouldn't use the product rule because you just have one T in the whole thing. And you use the product rule when you have two functions of the variable multiplied by each other.
We used it anyway and kind of got what you did. So
But-
it's
but-
kind of weird. But it
Yeah.
wouldn't.
Fundamentally, what you're saying is I took 24 as one of my functions,
Yeah.
but derivative 24 is 0, and it's just writing out extra work.
Yeah, I saw that.
Okay, so I'm going to do D, and I know I told you guys to go over there. I'm going to do it right here. First, I'm going to rewrite this. Like I said in class, we can make our lives much easier if we rewrite this as 7t times e to the 20t.
Yes,
It means exactly the same thing. And now I have to use the product rule because, like we were saying with Randy, we have one function multiplied by a second function. And so the product rule I have, if f is equal to xy, then f dot is equal to x dot y plus xy dot. Remember with the shortcuts, I'm doing this intentionally with the shortcuts. The dot means derivative with respect to time. And of course, my function is with respect to time, so it actually is working out for me. So then I'm just going to say, and I'm going to do this all kinds of long form, x dot, x is equal to 7t, so x dot is equal to 1 times 7 times t to the 1 minus 1 equals 7. And y equals e to the 20t, so y dot is equal to 20 times 1 t to the 1 minus 1 e to the 20t equals 20e to the 20t. Yes. For a minute there, I was worried, where'd the 20 come from? I don't see the 20 in my original problem. So now using my product rule, I have f dot is equal to x dot times y plus x times y dot, and then combining as I can, 7 times 1 minus 20t e to the 20t, or if you prefer, 7 minus 140t e to the 20t. Right, either one of those means the same thing. The second one is probably simpler to write. Did I make a mistake?
Where did the 1 minus 20 come from?
That's a plus sign. Can't you tell? It's that plus sign right there.
Okay, well, where did the 20t come from then?
There is an e to the 20t here and an e to the 20t there. There was a 20 here and a t there.
7 times 3.
Right, if you take, if you take these terms, 7, t, 20. And from the other one, the 7 was there, and 7 times 1. And both of them had e to the 20.
Right. That I get, but.
I know. My trying to illustrate how I got there is okay. So what are you not understanding, dude? His name's going to be Alex, and I've been calling him David all along. As I erase things, I erase too much.
I think I understand.
It's gone. Like half the problem's gone.
Because what you do is you crunch the first bit together, so you get 7e to the 20t plus the second bit, right? Because basically you just multiply the 7 in and e to the 20t.
By both.
And then you divide both by 7 to the 1.
Yeah.
Or you move that out. Okay. Yeah, yeah.
Okay. And do feel comfortable asking me questions if there's a confusion. Now, this last one is, yay, the hardest one.
Yes.
So I have this function. What rule am I going to have to use?
All kinds of rules.
All kinds of rules.
You're going to have to use or you can use the quotient rule if you want, but personally I like using the product rule. I don't use that.
That's actually what I do too.
You got to use cosine and cosine sine rules. Okay, question. Can you get rid of the t in the numerator that's out in front of the cosine?
I can, like you said, I always use the product rule. I never use the quotient rule. And so I'm going to do that.
Right, but
So I'm going to write this as t divided by t squared is t to the minus 1, right? Just like you did, Randy. So with it written this way, then I only have to use the product rule. Yes, Randy. Randy. Wow. David.
where did that first t to the minus 1 come from?
T divided by t squared is 1 over t.
Yeah, that was what I was curious about. Like, I was curious if you could cancel out the t in front of the cosine because the sine doesn't have a t in front of it. So
You have to divide both of them separately.
right.
Right, so that's why I have t to the minus 2 times sine t. Okay, so now we take the derivative of this. So I'm going to use the product rule 2 times. So in red, I'm going to do that one. So let's just call that G. And then in blue, I'll do this one. I'll call it H. So I think quite clearly, F dot is equal to, oops, I shouldn't have undo. I should not have underlined it because when you underline it, it looks like you're doing a division.
Actually, what I did, I just took, and made it U, V using the quotient.
Yes, but then you still have to use the product rule again.
Yeah.
And so you have, I just never use the quotient rule in my life. I just never use it.
It's hard.
I don't even have it memorized.
Yeah, it's far harder to memorize.
V
It's the same thing, kind of just like divided by UV.
T squared.
By v squared, but
I could figure out what it is because I have the product rule memorized. But yeah. So let's just do this. So let's do G prime. G prime is equal to, well, I have t to the minus 1 times cosine t. So using the product rule, doing the derivative of the first, I'm going to have minus 2 t to the minus 1
shouldn't that just be
cosine
No, it
t.
should be negative t and then to the
Yeah, you're right. I was thinking integral. You are right. It's good to be right.
And then
Plus
the negative 1 times the negative sign.
times negative sine of t.
no,
That's
the cosine should be a sine.
derivative of cosine is negative. Derivative of sine is positive. Just think about the graph. A sine wave goes like here's 0. The sine wave goes like that. So the slope, the derivative is positive at time equals 0. Cosine goes like this. So the slope starts at 0 and goes negative.
Oh.
Okay, so that's G prime. And then H prime, I'm saying prime and using dot, I should have said dot, is equal to negative 2 t to the minus 2 minus 1 sine of t plus t, no t, what am I doing? T to the minus 2. Yeah, my minus 1 disappeared. There. T to the minus 2 times cosine of t. So I didn't simplify like I should have. The G prime simplify or G dot simplified is equal to negative t to the minus 2 cosine of t
So what
minus
did you add it to?
t to the minus 1 sine of t. Sorry, what was that, Oksana?
What do you add it to? Like, I understand it's like negative 2 t and then negative 3, and then the sine t remains the same. But like, what are you adding it to? Like derivative of that?
Well, I'm doing the product rule. So because I did the product rule explicitly here, I'm not doing it quite as explicitly, but I have two things in each case. I have for G, I had t minus 1 was
Like
my,
you take the derivative of the function.
right. So minus 1 t to the minus 1 minus 1 is the derivative of t to the minus 1. And I multiply that by cosine t.
Right.
And then I put t to the minus 1 times the derivative of cosine t is minus sine t.
So you add it to the derivative. Well, I mean, you add
Well, the product rule is the derivative is the derivative of the first times the second plus the derivative plus the first times the derivative of the second. So I'm using this rule.
I've never had to add the derivative of using the product rule.
Yeah.
Am I thinking of the right one?
You know the product rule, right? U, V, or you use like X, Y.
Right. UV.
That's the product rule right there.
So UV is what? What's the rule? UV.
Oh,
Well, he was just U and V is the typical variables you see in your calculus book.
So in respect to that,
U and V are.
UV. Oh wow, I forgot about that. Okay, I'm back on the right.
Okay, and simplifying the H dot minus 2 t to the minus 3 sine t plus t to the minus 2 cosine t. So now if we add those together, f dot equals, and I'm going to combine terms by sine and cosine. So I'll have a negative with my sign there and a negative with my sign here. And so I'm going to put the sine term second. I have a negative with my cosine there and a positive with my cosine there. So I'm going to put that one first. And yeah, that's it. Those subtract out, don't they?
No, they don't.
No, they don't.
No, it's a negative 2 and negative 1.
Oh, right, because it's not added, it's subtracted.
Exactly.
Okay. Yes, G minus H, not G plus H. Whoops. All right. I am glad you said that. I was like, I didn't remember it being that simple, but sure. So combining those two, then it's Well, then that means sine's the one that's going to have positive.
That's where I
Yes.
stopped. I just
So I'm going to have 2t to the minus 3.
Minus 2.
That's this one here. Oh, you were.
Oh, I thought you were putting cosine first. Never mind.
Two and one. Oh, yeah, they wouldn't subtract the cosines. Where are they? Yeah, they would have. 2. Of course, I didn't like you. I wasn't like you, and that I didn't do these before class. Is that what you got?
Pretty close.
Pretty close.
Like, you just cleaned it up a bit for me.
no, mine was so far.
So the answer is the same. It's fundamental.
Yes.
Okay, because I mean I didn't do them before, and like you saw me forget a minus sign. People can make mistakes. I understand that. That's why we're going through each of these, so we can work things through. Question, Marcel?
Yeah, like because I used the quotient rule, so I didn't have like a lot to base off of. But my question would be, the reason why you decided to use the product rule is because you brought the numerator, the denominator to the top with the negative exponent.
The reason I use product rule is because that's what I'm comfortable. The method I did was to take the denominator and shift it to the numerator. 1 over, in this case, 1 over t squared is t to the minus 2.
Gotcha.
And so that was the method I used so I could use the product rule. Okay, first David, then Randy.
Can I take A on the integrals, please?
We will see.
That's not.
You are
What-
horrible!
What were you going to say, Randy?
No, I think we already talked about it. It's just we couldn't, we couldn't cancel out the t on top or anything like that. Just t squared.
Well, because there was a single t and no t, that we did end up with t to the minus 1 instead of t to the minus 2 because there was the single t in that term.
I see that.
I mean, if we could have canceled completely, yeah, that would have made life easier. But whoever chose this problem didn't do that.
Wow.
All right.
I'll do.
Oh, I can't erase that because that's on the PDF. All right, now we get to choose who gets to do these. So, who wants to volunteer for E?
I'll do D.
I was pretty sure no one's going to volunteer for E. So, Oksana will do D. And anyone want to choose C? All right.
No change of plans. I'll do B.
Woo! Then Richard gets to start.
Yes.
Go team. All right. I'm only going to have you do one. And I'll go ahead and do A since I have to do E. While you're up here working, I'm going to look up on Wolfram Alpha. What is the integral of this?
Did you pay for Wolfram Alpha?
No.
I think you need the pro version to see the.
No. Not yet.
I was looking wrong.
Because, like, in order to see the steps for Wolfram Alpha, you have to pay for it.
Well, I'm not looking at the steps.
He's just looking at the answer.
I got to show I know how to do my math. I didn't know that they would show you the steps, honestly. All right, so for mine, the easy one.
Shoot.
Yes, David?
Isn't B the one where I have to use local rule?
Nope.
Okay.
No. E is.
2 to the top.
Oh yeah, no, that's what I would do. Like, he said that we have to show like the limits and everything, which boggles me.
Over 2, 2, 4, 6,
It's tough.
10t squared. Wow, you really did.
Well, that's just right. The problem, I haven't started yet.
Yeah.
Well, yeah, but like, I would.
Now, some people feel more comfortable separating this into 3 integrals. Frankly, I don't care. Actually, those same people would put the constants outside. If I'm going to do it for those people, I'm going to do that too. Okay, so the second way of writing it, that's the simplest way of writing it in terms of easy calculus. But it means the same as the middle one, and the middle one is much easier to write. So that's the way I usually write it. You are free to do your math the way that works for you, as long as you're doing the math. So doing either one, of course, you get the same result. So I'm going to have equals 5t to the 2 plus 1 over the new power with my limits. Zero. Actually, I'm going to do all the limits together. Minus 20t to the 1 plus 1 over 1 plus 1 plus 17t to the 0 plus 1 over 0 plus 1. Whoever writes 0 plus 1? No one, except for when you're being ultra explicit. So, of course, this is equal to 5t cubed over 3 minus 10t squared plus 17t, 0 to t final. So I just simplified. 20 divided by 1 plus 1 is 10. It's the only simplification that is of any reward. And then I put in the upper limit first. So 5t final cubed over 3 minus...
That's not 5 over 3? Oh,
it's the same thing.
Okay.
So there I put the upper limit minus the lower limit.
Brr.
Now notice, in this case, but certainly not in the next case, all of the ones where I put in 0 for my limit were zeros. And so my answer is simply 5/3 t final cubed minus 10 t final squared plus 17 t final. Now, an important thing to note, what happened to the constant plus c?
Yeah, no, we do need that.
No, we don't.
Why not?
That was my question.
I don't know.
Okay, that's a good answer. Anyone know?
Because we have TFs, right?
Because we have limits.
That's right.
The
I
plus
call
c
them
only occurs if you don't have limits.
I call them downs. I don't know what you see.
Do what?
I call them downs.
Do you?
Yeah.
I thought I heard downs, bounds.
Oh.
Yes, bounds is fine. Okay, I believe David is up. So come on up.
Okay. So we start with f of t equaling 6 over t squared. First thing, I like to reshuffle it around, so I get f of t equals 6 to the t to the negative 2. So now we got to do our fun derivative stuff. I mean integral stuff. So integrate from 0 to t final of f of t equals the integration of this f of t of 6t to the negative 2 dt. Okay, so then we've got equals. I'm going to put my bound right there. So we've got 6t negative 2 plus 1 over negative 2 plus 1. And that's going to be f sub. That's not right. Yeah, it's t to the final. I did that for a number of these, or one other. Okay, so that's t to the final, t to the final. There we go. Okay, and so now we do some arithmetic, and we come up with 6t to the negative 1 over negative 1, 0 t final. Scroll down a bit more. So then we've got negative 6 t to the negative 1, 0 to t final. And before we move the t back down to the bottom, let's put in the limits, I guess. So we've got negative 6 t final to the negative 1 minus negative 6, 0 to the negative 1. My word, I take up a lot of space. Okay. Never used one of these before.
Don't worry. We don't need to calculate. What's 1 over 0?
Oh, that's undefined.
So what's your answer?
Undefined?
The answer is undefined?
Yes. Because what happens, as Dr. Webb just pointed out to me, you've got this negative 6 over t final, and that's the one is now positive. My t is atrocious. So that's what the first
6 is what's atrocious. Your t is fine. There we go.
That's more better. And then what you would have is plus, because you have a minus negative 6, so that sign changes 6 over 0, and you can't do that. So the answer is undefined.
The answer for the whole thing is undefined because adding up. Yeah. Perfect.
I had his answer at the beginning, so I forgot about that.
So what does this do exactly?
What do?
This is due tonight at like.
Oh, when is this due?
So I turned it in.
You can always redo it. Okay, I forgot who was next.
I'm gonna try to do this one.
Okay. Oh, look at the time. We're just not going to get to do TE.
No, unless I take a while. Or
Wait,
don't take a
does that
while.
mean we're on we have to do 2E on our own?
I'll
24
stay
error.
late if you have time, but I am not going to force you to stay.
Or put it on middle.
It's already on OneNote, so you can.
Oh, the answer's on middle?
Well, what we're doing is on OneNote.
All right. I first started by just setting out the problem, I guess, put in the integrate form or sign and everything like that. So t final. This is our 0. And then, of course, it's 24e3t dt. Now, I believe for like the e to 3t, we have to use U-Substitution.
Well, I suppose you can, but it's simple enough that I never do.
No, because I did need a little bit of help on this. So what I did was found the answer, and then I was just like, it kind of makes sense. Don't I basically bring out the 3t, which is the derivative, e to the 3. It's 24 divided by 3 in a way.
The rule, using the fundamental theorem of calculus, which is what I told you to use for e,
Mm-hmm.
you know that the derivative of e to the 3t is you bring down the derivative of the exponent.
Mm-hmm.
So the integral, you're
Would
going to
be
be dividing by.
That's what I thought too.
which is fine as long as you don't have a complicated exponent.
Which I don't think.
So
3t.
the derivative of the exponent is 3, so you just
Let's
divide by 3.
Right. So basically, can I just show it instead of writing it out more than I should?
And then the limits.
Right. Limits. So we basically plug in t final for t and then t final for 0 to subtract as we need to. So this would be 8. 24 divided by 3 is 8.
Draw your intermediate here with the brackets around it and the limits.
As in this.
That, yeah.
This is t final. 0. All right, so basically it's 8e3 t final minus 8e3 multiplied by 0.
Right.
So this would be, doesn't matter. That's fine. 3 times 0, 0. E to the power of 0. E to the power of 0. That's just a number times 0, which would be 1, right? So that's just 8 times 1 minus 8e3 t final.
And that's your answer.
And that's our answer. Yes. Everything just multiplied by 8 over here. Put it in simpler terms. No, it didn't matter. Yeah. I just thought it was the same
Well,
thing as soon as I did it.
you make it 8 times e to the 3tf minus 1.
Mhm.
It's 6 1 half dozen of All right, excellent. Ms. Busta.
All right, I'm gonna take a crack at it.
Speaking of cracks,
This one's not too
Oh, you put it where it was supposed to be. Okay, so
Sorry, it's a happy.
you what?
sorry, I should never put it where it's supposed to be. What was that?
I know. How dare you? So. Can you guys see that?
Oh, we can see what you're writing.
Okay. All right. So.
You knew what we did earlier with the derivative thing?
You what?
Just combine.
Yeah, making a simple form. Yeah,
Yep. So we're just going back to that.
thank you. Well, she forgot to put the DT the first time.
Well, yeah, but you can put the 7 out front,
Well, it's a constant. Yeah.
Because it's
Constant.
it's the constant. You can bring it over. And so I'm going to use a thing called integrate by parts, where t is my u and e to the 20t is my dv.
Except for you need to include the DT and the DV.
What was that?
You need to include the DT and the DV. It's not.
Oh, that's true. That's true. I forgot about that. Okay.
Integration by parts is the reason this one's on the list.
And integration by parts is u dv equals ub minus the integral of v du. You've heard this, right? It's a formula for integral by parts, and so these pieces right here create this. For instance, u equals t, and then du is the integral of t is 1. I'm sorry, the derivative of t is 1. Well, dt, gosh. And then v, well, dv is what we have right here, so we're going to be taking the integral of that. So dv equals e20t dt, because this right here is the piece we have here. So now I need to find the integral of that, and we already kind of know, because 20t, and then the integral of that be 1 over wait, what is it? Huh?
That's the derivative.
That's the derivative. That's
Yeah.
So the other way
e
would
to
just
the
be
20t over 20 is
Yeah.
what the integral is.
Yeah, so it's 1 over 20e.
No.
The e
20t
is on
is the
top.
numerator.
It's numerated.
Okay, so
Using the right words.
where did I
Some
put it?
education.
We're good for a freshman. Oh wait, you're sophomore this year.
Right. I am a sophomore this year.
He's returning student.
Oh,
Graduated. But he introduced himself as a sophomore. Last year as a freshman, they put him in core class.
They did. It was hilarious. But this guy's like, get out.
Okay, so that's V right there.
This is v. And now we can just plug it all in there. So the integral of t, and then that's dv, which we already have. And you multiply that with e20t dt. Well, okay, so you can say dt equals, oh yeah. Okay, so that's what's happening there. Where am
Try to find.
I? Oh, so I have dv,
And then
which is that.
down V up there.
Right. This is a new.
And then minus, no, that equals uv.
T times E20.
UV. Oh, UV, yeah. Why am I sucking at this? And then,
Right, that's the first term.
that, right?
Yep.
And then minus integral of v, which is e t 20, then du, which is just dt.
Okay, now, for time purposes, I'm going to stop her because our class time is technically over. I will finish up real quick because she's done the hard work.
Yes, you have. One thing she didn't do here is you do need to put the limits. So the UV is actually, and I never saw this when I was in calculus class. But you have the limits there in the UV, right? Because and it's not just the limits on V, you're doing UV and applying the limits. So putting those limits everywhere. Integration by parts.
Yeah, no, I don't remember that.
All right, so now what she has, if we put in if we do that second integral is just like the one she did before, except for dividing by 20 again. So it's going to be divided by 400. That's how we got 400. So what we have is t times 1 over 20 minus 1 over 400 e to the 20t with my limits. So I combined the integral is the second term in parentheses, and then the first part, the uv, is the first term in parentheses. Except for I made a mistake. Of course I made a mistake. The t was only multiplied by the front term, not by the second one. So now we put in our limits. So when you put in those limits, you have putting in the upper limit first, t final over 20 minus 1 over 400 e to the 20 t final, and then subtract the limit with 0 minus 0 over 20 minus 1 over 400 e to the 0 t final over 20 minus 1 over 400 e to the 20 t final plus 1 over 400. None of these feel familiar to me because I changed all the problems up last year. So I'm like, really? I hope it's right.
Can you quickly go over that integration by parts?
Yes. The integration by parts? Yes. So your time is up. If you need to go, feel free to get up and go. Okay. I don't want anyone to feel like, oh, I had to stay late for class. Integration by parts is if you have the integral of two functions is hard, but if you were to take derivative of u and integral of dv, it would be easier. Yes, that's a v and I wrote it like a u. Okay, so you have this. If that's hard, but it would be easier. Okay, so it's not always useful. It's got to make it easier for you. And sometimes, like in calculus class, we had to do recursive integration by parts, where you do it twice and you get back to the same integral. And then you make an algebraic equation to solve for the integral. First time I did that, I was like, what? So what you do is you need to identify, this function, if I take a derivative, it gets easier. So if I'd had, instead of t e to the 20t, if I'd had t to the 5th e to the 20t, I'd say, if I took derivative of t to the 5th, I'd be down to t to the 4th. If I took 4 more derivatives, I'd be down to a constant, and it would be easy. And so I would end up, and we did, at least in my practice, we did this. We did integration by parts like 5 times to get to the answer. We do that in physics, sadly.
Like it just worked out.
So, this one I showed this, you only had one because don't want to make life hard. We're just making sure we can do the math. So you have to identify what's going to be useful for you in DV, right? It's not generally going to be sorted for you. So, the first part is U and the second part is DV. You have to go through the thinking of how to separate it. And it is the reverse of the product rule. And so, you can derive it easily enough. I can't do it right now. I'd have to sit down and think, but I've derived it in the past.
Okay, so what is the equation?
So if that's the case, then integral of u dv is equal to uv minus the integral of v du.
Never asked it.
So that's the thing in the box is the actual product rule. The part above it is when are you going to use it. And it very much is you kind of got to feel it out. Right? Unless you're in a calculus class that says solve this using integration by parts, you've got to feel it out. Is that going to be the way to do it? So in this problem, Oksana recognized, oh, I have t multiplied by an exponential. The exponential doesn't get any harder when I integrate or to differentiate it. But the t, if I differentiate it, is going to make it easier. So the t is going to be my u, and then the exponential is going to be the dv, is the thought process she had to go through. And then once she had done that, then all of the work she did is what you do. You identify the u, and you take the derivative of u to get du. You identify dv, and you integrate dv to get v.
Okay, I get that now. What happened to the 7 constant?
Did we forget the 7? We probably did. Yeah, we forgot the 7. The 7, it should have been that u is, well, she brought the u out. So my answer is there's a 7 out here. Hence, there's a 7 there. So what happened was the 7 was factored out. I forgot about the 7. It's too far in the past.
Okay.
Okay, last problem, so you can see it done and see L'Hopital's rule in action. So here is the problem. F of t is t cosine t minus sine t all over t squared. I figured it would come into focus before I left. So we've got some really big writing. Now we'll go to small writing. And you're probably wondering, why did he choose this crazy thing to begin with? Well, here's why I chose it. If you put this into Wolfram alpha, the integral of f of t dt, it tells us, is sine of t over t plus constant. That's what Wolfram alpha tells us. Notice there's no limit, so that's why there's a plus c. So, I mean, I plugged it into Wolfram alpha. I didn't log in or anything. It just gives me that. So there's no subscription or anything required for this. And the problem says, I don't expect you to solve this, right? To solve this, well, you could have done integration by parts. You would have hated life. I actually did that once, just to make sure I could do this integral. And it's a lot of work. So what I told you to do is use the fundamental theorem of calculus. Get practice with another idea that comes and goes instantly in calculus class. So who remembers the fundamental theorem of calculus to show me that I'm wrong? No, right? I was right. It comes and goes. I remember my teacher talking about it and me saying, okay, duh, and moving on and never thinking about it again. But there are times when it is useful. Here's the fundamental theorem of calculus. d dt of the integral of f of t dt must equal, what must that equal?
The area under the curve.
Well, integrals are areas under curve. Derivatives are slopes, but what must that equal? What's the derivative of an integral equal to? Yeah.
What? It should be.
No, the derivative of an integral is the original equation.
That's the fundamental theorem of calculus. The fundamental theorem of calculus is essentially the integral is the antiderivative. In fact, in my calculus class, it was introduced as the antiderivative, and the next day we did integrals, and my brain didn't connect the two. And so from there on, for the next chapter or two, sometimes it would say do the antiderivative, sometimes it would say do the integral. And I did, if it said do the antiderivative, I used that stupid formula we had to use when they first introduced it. And if it said find the integral, then I used the rules we're using today.
Antiderivative, isn't it the just to get it going?
Yes. Yes, but my brain didn't make that connection.
Oh, gosh.
But that's what the fundamental theorem of calculus is that the integral is the antiderivative. So what we're going to do now is we're going to check and see if the derivative of this solution, so here's the solution, if the derivative of that is really the function we have. If it is, then I can be comfortable that Wolfram alpha gave me the right answer. Because believe it or not, it's possible to get wrong answers from websites or from calculators. When I was at PUC, one of my colleagues would allow students to use their calculators on tests in calculus, but he chose problems that the calculators would give incorrect answers to.
What?
Well, he told them you have to do the integrals using calculus. You can't use your calculators to do the integrals. And if they did, they would just get the wrong answer.
Okay, that makes sense.
Okay, so let's do this. Let's take the derivative of sine t over t plus c. So the derivative of sine t over t, once again, I use the product rule.
Okay.
You could use the quotient rule, but you'd have to know what it is. So what is the product rule? Well, I have and let me put this here. d dt of c is a separate thing. What's the derivative of a constant?
Nothing.
Yeah, so I put that out as a separate thing so I could instantly put that to 0. Don't want to worry about that. So now for the product rule, I have the derivative of t to the minus 1 is minus 1, t to the minus 1 sine of t, and then plus the first, t to the minus 1 times derivative of the second. Derivative of sine t is cosine t.
Oh, I see.
And so there I've done the product rule. And, you know, most calculus students would say, you're crazy. Just use the quotient rule. It's a perfect quotient rule problem. And if I'd done the quotient rule, it would have given it to me in the same form that I gave it to you.
It's just so much harder to remember.
That's right. So notice I had this term was t to the minus 2. And so I'm going to divide top and bottom, or multiply top and bottom by t squared.
Wait, why are you doing that again?
Okay, I should have done it like this. I'm multiplying by 1, multiplying
Right.
top and bottom by
Yeah,
t
yeah,
squared.
yeah.
So that the t to the minus 2 will cancel,
Oh, okay.
and the t to the minus 1 will become a t. And so that's going to be t cosine t minus sine t over t squared. And so now we just have to check and make sure, and that is what I put in Wolfram alpha, but make sure I put the right thing into Wolfram alpha. T cosine t minus sine t over t squared. Good. So we verified that sine t over t is my integral. Now what about the plus c? If I didn't have limits, I'd put plus c. Since I have limits, I'd not put the plus c in. Yes?
Just real quick, a little bit.
Yeah.
For the product rule, I like to write it out just to make sure I'm not mixing anything apart. So I put the u and prime equals this thing. I just to piece it together so I didn't follow completely. But you said you multiply by t squared divided by t squared.
Right, so I multiply top and bottom by t squared. Just so, remember, I have the, give me the black pen. I have here t to the minus 2, that's not the black pen. It said, so, oh, brother. So t to the minus 2 there, if I multiply it by t squared, that's just going to be 1. And so I have minus sine t here. Right there. And then this one here, t to the minus 1 times t squared is t, so I have t cosine t there. And then I have over t squared because I had to multiply t squared divided by t squared. So over t squared for the whole thing. It was just a way of getting the common denominator.
Oh, yeah, I see.
So how do you apply the limits on this? Because you.
Okay, well, I haven't actually started the problem per se. I verified I haven't started the limits.
Right, okay, so you just, this was just
I verified that Wolfram Alpha's solution is indeed the right solution.
Okay.
And so now that we've done that, now I'm ready to say the integral from 0 to t final of t cosine t minus sine t over t squared dt is equal to sine t over t with my limits from 0 to t final. So now we look at this. The first one's fine, right? T final, unless T final is 0, that's going to be defined. But the second one, sine 0, what's the value of sine 0?
0.
0. Divided by 0. So that's 0 divided by 0. 0 divided by 0
Some kind of.
is indeterminate. It's not undefined, it's indeterminate. And so the difference is undefined means it has no definable value. Indeterminate means it could have any value. So there's a significant difference because we have 0 over 0. Anytime you have an indeterminate limit in an integral, remember these are limits. Then we have to go back to, okay, so what is a limit? And so you learned long ago, so the first term is gold. That one stays just like it is. So everything I'm going to do now is only going to be looking at this. And notice there's a minus sign. I'll worry about the minus sign when I'm done. So the blue stuff is going to give me the value that I have to subtract. So what that really is the limit as t approaches 0. Remember, I've been calling the limits all along. So it's the limit as t approaches 0 of sine of t over t. And so L'Hopital's rule says that the actual value it has depends on how quickly they're going towards 0. So if they're going towards 0 let's take an example. In physics, we actually abbreviate L'Hopital's rule by saying there's different orders of infinity or different orders of 0. By how quickly is it going to infinity? So if I have, let's say, x cubed versus x, which one's going to infinity quicker as x approaches infinity?
X cubed.
X cubed. And so if I had x cubed divided by x, it would be infinite because the top one's going to infinity first.
X cubed divided by x.
Yeah. And if I had x over x cubed, what would the limit be?
We head towards 0 because the cube is smaller, or bigger, excuse me.
Yeah.
The denominator is bigger.
So it would be infinite or 0 in that case. And I know this one's really dumb, but I have to say it. If I had 5x cubed over 3x cubed, as x approaches infinity, what's it approaching?
5x cubed. Well, 5 is the higher number. It's
5
over 1.
thirds.
It's approaching 5/3 because the x cubed parts are approaching infinity at the same rate.
Oh, yeah.
So the ratio is approaching 5/3. And normally we would have canceled, but what if you had 5x cubed plus 3x squared plus 7 and 3x cubed minus 100x squared plus 10? Well, the highest power is the one that's telling you how quickly it's going to infinity. The rest of them aren't, so you just throw away the rest of it and only use those highest powers.
Right.
Okay, so L'Hopital's rule is the formal way of doing what we in physics do quickly, just by using those fundamental rules. Problem for Nathan when I was helping with calculus, of course, I'm telling him how we do it in physics. Oh, wait, no, you need to do it the right way. So what we do here is L'Hopital's rule says in the case of an indeterminate, so this is only the case if this is indeterminate. which means something that's 0 over 0 or infinity over infinity, or since this is equivalent, 0 times infinity. 0 times infinity is equivalent. You're going to have to change the form to make it so it matches one of the first two. But I put that there so you recognize, oh, that's also an indeterminate form. Then this is equal to the limit as t approaches 0, or t approaches whatever, where it's indeterminate, of the derivative of the top. So in this case, that's the derivative of sine t, divided by the derivative of the bottom.
And the derivative of the top is cosine t, and the derivative of the bottom is 1. So just limit as t times 0 is cosine t.
And what is that approaching?
1.
1. The answer. And so
then the final answer is sine of tf over tf minus 1.
yep. So that's how we use L'Hopital's rule.
That's a handful.
Yeah, it kind of is.
See.
Any questions?
Not on this one. Can you scroll back up to D so I can finish writing stuff down?
Scroll back to where?
D. So that one.
The different terms one, the U and the DB.
This is D right here.
Okay.
That's it in its entirety.
How do you want us to turn this in? Is there a page on?
Yeah, on Moodle, just like with your lab, put it into one PDF document and submit it.
Has already been due?
I know, it's due tonight. Right, so you had time to now incorporate what we learned in class.
Yeah.
Now that we've done all the problems.
Show me what it is real quick.
That's
Oh.
so you got 11 hours. This is that document.
You said it was on OneNote, so there's a link for OneNote, right? Everything we do here is somehow.
You should have gotten an email with the link for OneNote.
Oh, it was from you. I'm assuming nobody else.
Yeah.
What's here?
Right. It was from me.
Look into that.
If you don't have access, so everything that we did here, you have available to you right now.
Nice.
Oh,
So if you don't have access to OneNote, let me know.
I'll look for those emails. I'll email you if it doesn't.
All right.
A lot of emails.
Yeah, but I don't spam you that much. Not like Union